Hello everyone. On this video we will be looking at the unit circle, or more specifically points on a unit circle. Okay, so let's start off with exactly what is a unit circle. Alright, so if you remember, you have the formula for a circle, which is x minus h squared plus y minus k squared equals your radius squared. Okay, where we know that the center is equal to whatever h and k happens to be, and the radius, which is your r, is your r. Okay, now a unit circle is just a specific circle. It's just a circle centered at the origin 0, 0. Remember, that's the origin, with a radius of 1. Okay, so remember, your center is the h and the k, where in this case the center is 0 and 0. So we replace our h and our k with 0. So you get x minus 0 squared, which is just x squared, plus y minus 0 squared, which is y squared. So you have x squared plus y squared equal a radius of 1, so r is equal to 1. So you end up with x squared plus y squared equals 1. And this is your formula for a unit circle. So if we wanted to kind of look at how it's drawn, if you look at it that way, you have your x and you have your y-axis. Your unit circle goes from the origin all the way to the circle, really in any direction. Your radius is going to equal 1. So if you go in this direction, it's going to be 1. This direction is going to be 1, even though my off-center circle doesn't look like it. Any direction is going to be a radius of 1. All right. Now, when messing with our unit circle, we have to remember one of many things. One thing we have to remember is that there are 4 quadrants. On the XY plane. Okay, so for those 4 quadrants, just writing them out here. Now you're going to go counterclockwise. Which means you're going to start here and go this way. Okay. So this is quadrant 1, where all values are positive. Because remember, it's still your x and your y-axis. So your x and y-axis are both positive in quadrant 1. So you kind of focus that a little bit better. There's a little bit better. Okay, so you have quadrant 2, But remember, this is your x-axis, so all the x values are negative. Your x are negatives and your y is positive because it's above the x-axis. Then you have quadrant 3, where your x is negative and your y is negative. Then you have quadrant 4, where your x is positive and your y is negative. Alright, so that's a quick explanation of our unit circle. So if you're still writing, feel free to press pause. We're going to go ahead and jump into an example. Okay, so what if we wanted to show that negative 5 over 13 and 12 over 13 is on the unit circle? Okay, so how do we do that? Well, we remember that our unit circle is x squared plus y squared equals 1. That's our unit circle. Okay. We also remember that our ordered pair is x comma y. That's your ordered pair. Okay. So what we do is we plug in this x and this y, and if it equals 1, we know it's a point on the unit circle. Okay, so we just plug in x and y, where of course this is your x and that's your y. So you have x squared plus y squared equals 1. So that gives you negative 5 over 13 squared plus 12 over 13 squared equals 1. So if this side equals 1, to match this side, we know it's true. True if both sides are equal. Alright, so any negative squared is going to come out positive, so we're okay there. So you have 5 squared, which is 25, over 13 squared, which is 169, plus 12 squared, which is 144, over 13 squared, which is 169, equals 1. Okay, so 144 plus 25 is actually 169, since you have the common denominator. That gives you 169 over 169, which is equal to 1. Anything divided by itself is 1, so that just gives you 1 equals 1, which is true. So this point is actually on the unit circle. Alright, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so let's say, for example, we want to find the y coordinate of square root of 3 over 2 y on the unit circle in quadrant 4. Okay, and knowing what quadrant it's in is very important. Okay, that's very important information. Okay, so we want to know, well, really we just want to plug that in. So we know that x squared plus y squared equals 1 is our unit circle. Okay, we have our x. Okay, so we just go ahead and plug in that x. So we have square root of 3 over 2 squared plus y squared equals 1. Alright, so square root of 3 squared is just 3. So that's 3 over 2 squared, which is 4, plus y squared equals 1. So if we go ahead and subtract 3 over 4 on both sides, that's y squared equals 1 minus 3 over 4. Alright, so we have, if we make this 4 over 4, we have 4 minus 3 over 4, which is 1 over 4. So y squared equals 1 over 4. So if we square root both sides, we have y equals positive or negative square root of 1 over 4. Where square root of 1 is just 1 and square root of 4 is 2. So y is equal to plus or minus 1/2. Excuse me. Now, this is where knowing what quadrant comes in very, 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 very handy. Okay, because if you remember, I'll go ahead and draw it here. This is quadrant 4. Okay, so we know that x is positive. That's your x and that's your y. So in quadrant 4, x is positive and y is negative. Okay, so since y is negative in quadrant 4, we know we pick the negative 1/2. So y equals negative 1/2. Okay, so that's why knowing what quadrant is very important for this one. All right. Now, if you would have said it's in quadrant 2, then we would have picked the positive 1/2 because y is positive in quadrant 2. But because it's at quadrant 4, we know it's negative. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next page. And we're going to look at some of the, I guess you could say, the basics of a unit circle. And those are your unit circle points, at least the points on the x and y axes for now. Okay, we'll go a little bit deeper as we move on. All right, so we have our x and y axis. Okay, and let's say that's our unit circle. Remember, it's a radius of 1. So if you go from the center to this point on the x-axis, that point is x equals 1, y equals 0. You go from the center to this point on the y-axis, that's x equals 0, y equals 1. So if you go from the center to this point on the negative portion of the x-axis, that's x equals negative 1, y equals 0. And from the center to this point on the negative y-axis, that's x equals 0, y equals negative 1. Okay, so now we're going to look at what we call a terminal point. Okay, the terminal point is found counterclockwise when t is greater than 0. Okay, and what do we mean by that? Okay, so let's go ahead and draw another circle. Alright, so let's just pretend that's a unit circle. A little uneven, but you get the idea, hopefully. Okay, so remember, you always start here when you're moving along a unit circle. Okay, you start at the positive x-axis. Okay. Now, when t is greater than 0, you're going to go to this direction. So you're going to go counterclockwise. Okay, so your graph goes in this direction. And wherever it goes from this direction and stops, at whatever point, that's your terminal point. So we'll call it point P of XY. Okay, so whenever you start here, you go in this direction, it's positive. Okay. Now, whenever you have a angle that's negative, then you're going to go in the clockwise direction. Let me kind of separate that a little bit. The terminal point is found clockwise when t is less than 0 or negative. Alright, so if we draw another unit circle, and I'll just go ahead and do that there. And it doesn't have to be a perfect unit circle, just for explanation purposes. Okay, so again, you're starting at your positive x-axis. And now, if your t is less than 0, you're going to go in the opposite direction. However far you have to go, depending on the value of t. And wherever you stop is your terminal point. So we'll call that Q of XY. Alright, so to give you an idea of how we're going to start marking our unit circle, yep, move that up, there we go. Again, not very pretty, but hopefully you get the idea. Okay, so let's say here when you're starting at your positive x-axis, you're starting here, this is where t is equal to 0. Okay, so when you go from here up to your y-axis, you're actually going from 0 to t equals pi over 2 radians. And I'll erase that y. Okay, so whenever you have that 90-degree angle, that's pi over 2 radians. Or 90 degrees. Okay, but if you're going from t equals 0 all the way to here, then that's t equals pi, or 180 degrees. Okay, so if you're going all the way, starting at t equals 0, you're going all the way around until you reach this point, then this is t equals 3 pi over 2, or 270 degrees. All right, so if you start at t equals 0 and you go a complete circle right back to where you started, one full circle is 2 pi, or 360, well, 2 pi radians, or 360 degrees. Okay, so a full circle is 360 degrees. Okay, so if you want to remember this using degrees, you can really count by 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36. 9, 18, 27, 36. So you know each one. If you're doing it by radians, you have 0, you have 1 pi over 2, which is just pi over 2. We have 2 pi over 2, where the 2's cancel out and you just left with pi. You have 3 pi over 2. Then you have 4 pi over 2, which is 2 pi. Okay. So you can actually count either way to help you sort of visualize it. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next page. Alright, so now, again, we're going to draw another unit circle. Again, it doesn't have to be perfect, just for visual effect. Okay, so we have our x-axis, and we have our y-axis. Alright, so let's say we're going to go from here to here. And we're going to stop at this point, which is going to be some x, comma, y. Okay, so what we're going to do now is we're going to convert this using theta as the degrees that we're moving up. Alright, so remember, from the origin to any point on the line, your radius is equal to 1. Alright, so since we're going to any point on that line, let's just draw this right here and make that a right angle. Okay, so we know from this point to this point, this is your y, and from this point to this point, this is the length of your x. Alright, so we know that y over the radius is equal to sine of theta, and x over the radius is equal to cosine of theta. Okay, since your radius is equal to 1, that just tells us that y over 1 is y. So sine of theta is equal to y. And again, radius is equal to 1. So cosine of theta is equal to x over 1. Or just x. So if you wanted to write your point here in terms of theta, your ordered pair x comma y in terms of theta, replace x with cosine of theta and y with sine of theta. Okay, so that's your ordered pair, but written as a term of theta. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay. So for example, if the terminal side of the angle goes through the point 2 square root of 5 over 5 and negative square root of 5 over 5 on the unit circle, then what is sine of theta? And actually, this is somewhat of a deceptively easy question. Now, what makes it easy? You have 2 square root of 5 over 5, negative square root of 5 over 5. Okay, so I'm going to cover this up for a quick second, but looking at our previous page, remember, this is your x, this is your y. So since this is your x, and this is your y, they just asked, what's your sine theta? That means your sine of theta is just your y value, negative square root of 5 over 5. All right. So again, that's one of those where looking at it, you would expect to have to do more work. But if you understand the actual idea of your unit circle and your sine and cosine as a point on the circle instead of your x and y, it's pretty straightforward. All right. So we have a little room left on this page, so let's do another example under this one. Okay, so for this example, what if we let the terminal side of the angle theta intersect the unit circle in the first quadrant Remember, when they mention a quadrant, it's important. At x equals 3/8. Okay. So what are the values of sine and cosine? Okay, so they actually gave you half of the solution. Remember, your x and y equals cosine of theta, sine of theta. But we know that our x is equal to 3/8. we know that that's our cosine. And our sine of theta is y. Now, since we know it's on a unit circle, we just use the same formula that we did before. X squared plus y squared equals 1. Which just becomes, x squared is 3 over 8 squared. Plus y squared equals 1. Okay, so that becomes 3 squared is 9 over 64. So if we subtract that from both sides, actually this becomes y squared equals 1 minus, I'll just rewrite it, 3 over 8 squared instead of skipping steps. So that becomes y squared equals 1 minus 9 over 64. Well, y squared equals 1 over 1. We can make that 64 over 64. So you have 64 minus 9, which is 55. So you have 55 over 64. So if we square root both sides, we have y equals plus or minus square root of 55 over square root of 64. Square root of 64 is just 8 over 8. But we know it's in quadrant 1. In quadrant 1, x and y are both positive. So this is just positive. So y is equal to square root of 55 over 8, which is our sine of theta. So that means our cosine of theta is our x, which is 3 over 8. And our sine of theta is our y, which is square root of 55 over 8. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, so for this example, we want to find the terminal point of the unit circle determined by so for problem A, t equals pi over 2 radians. Problem B, t equals 5 pi. And for problem C, t equals 5 pi radians. And t equals negative pi over 2 radians. Alright, so we're going to draw like mini unit circles for each one. So for problem A, you have your x and you have your y. So if we draw a little mini unit circle there, we're looking for pi over 2 radians. Okay, remember you're starting here at t equals 0. Okay, so you have t equals 0. And pi over 2, remember, starts here and goes up to this point. That's your pi over 2. Okay, so that's your t equals pi over 2. Let me get rid of that y. t equals pi over 2. Okay, so for problem B, again, we're going to draw our little mini unit circle. You have your x and you have your y. Okay, now remember, this is pi over 2. This is pi. This is 3 pi over 2. And this is one complete circle is 2 pi. Okay, so if you're counting, you have 1 pi, 2 pi. So starting there again, if you go one more pi from 2 pi, that's 3 pi. And if you go one more, that's 4 pi. And if you go one more, that's 5 pi. So you actually went around 1, 2, 3, 4, 5 pi. To stop at this point. So the point is -1, 0, which is right there. All right. Now for problem C, again, we draw a little mini unit circle. We have our x and we have our y. Now, whenever t is less than 0, remember, you go clockwise. So we're going to start here, t equals 0, but we're going to, instead of going here to pi over 2, this will be negative pi over 2. Okay, so t is less than 0, opposite direction. Okay, so actually this is your t equals pi over 2. I mean negative pi over 2. All right. Okay, so if you are still writing, feel free to press pause. But we're going to now look at some special values of trig functions. Okay, so these are values that you will want to memorize. Values of trig functions on a unit circle. Okay, so what we're going to do is make us a little nice, neat little chart or table. Okay, so these would be your theta values. And I'll move that over there. Okay, and these are your x values. Actually, I can give the theta one a little more room because I want to put the degrees there, degrees and radians there. So I'll give that a little more space. Okay, so these are your theta values. Your x. That's your y. And this will be your terminal point. Okay, so let's say theta equals 0 radians. where x is equal to cosine theta and y is equal to sine of theta. Okay, so cosine of 0, that's equal to 1, and sine of 0 is equal to 0. So your terminal point will be your x comma y, or 1 comma 0. Okay, so let's look at pi over 6 radians. Okay, pi over 6 radians, square root of 3 over 2. Okay, so cosine of pi over 6 is square root of 3 over 2. And sine of pi over 6 is 1/2. Which gives you the terminal point, square root of 3 over 2, 1/2. Okay, so your pi over 4 radians, cosine of pi over 4 is square root of 2 over 2. And sine of pi over 4 is square root of 2 over 2. Which gives you the terminal point of square root of 2 over 2, square root of 2 over 2. Okay, so pi over 3 radians, cosine of pi over 3, 1/2, and sine of pi over 3, square root of 3 over 2. Leaving you the terminal point, 1/2, square root of 3 over 2. So let me clean up that 3 a little bit. There we go. And last but not least, pi over 2 radians. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, which leaves you 0, 1. Okay, now we will cover converting a little bit later, but pi over 6 is actually 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. And pi over 2 is 90 degrees. Alright. So now what we're going to do is we're going to put that all on a unit circle. So what you might want to do, if you're still writing, feel free to press pause and finish this up. But if you can, try to print up, you can go to any number of sites and print up a blank unit circle. Alright, so what we're going to do is we're going to fill all these up. Remember, this is your x-axis, and this is your y-axis. Okay, so what we're going to do is we're going to start with your y values. Okay, so from t equals 0, you go up here, this is your pi over 6. Then you go up, this is pi over 4. Then you go up, this is your pi over 3. And this is your pi over 2. Or 30 degrees, 60 degrees, 45 degrees, sorry about that. 60 degrees, and you're 90 degrees. Okay? Now I'm going to give you a hint, because remember, this is just your x and your y, or your cosine and your sine. Cosine, sine. Remember, that's your ordered pair. We're doing everything in cosines and sines now. Okay, so here, this is the trick. And actually, let me get a sheet of paper, kind of show you what I'm going to do. And we're going to start with our y. So, oh, pencil leg broke. Let me do a little extra. There we go. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. That's the trick. And this is why we're starting with our y. Because square root of 0 is 0, so that's just 0 over 2 is 0. Square root of 1 over 2 is just 1. Square root of 1 is 1, so that's 1/2. Square root of 2 over 2, that can stay the same. Square root of 3 over 2 can stay the same. Square root of 4 is just 2, so you have 2 over 2, which is 1. This is the pattern from here on up for your y values. Okay, so square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. And square root of 4 over 2 is just 2 over 2, or just 1. Now, for your x, you go the same values, but the other direction. Square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. Square root of 4 over 2 is just 2 over 2, or just 1. Alright. So now we're going to go ahead and move on to quadrant 2. Okay, so this is 90 degrees. If we move a little further, this is 120 degrees, or 2 pi over 3. Okay, this is 135 degrees, or 3 pi over 4. Okay, and this is 150 degrees, or 5 pi over 6. And remember, when you go from this point to this point, that's 180 degrees, or just pi. Okay, and again, starting with your y's, you're going to go up, then you're going to go down. Okay, so square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. And square root of 4 over 2 is our 1. Okay, now we go the other direction. Square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Little bit of room, and I'll tell you why. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is square root of 3 over 2. And square root of 4 over 2 is just 1. Okay, now there's a reason we left a little bit of room in front of our x values here. Remember, on this side of the origin, all your x values are negative. Remember, x is positive on this side, x is negative on this side. So all of those x values are now negative. Alright, so now let's go on over to quadrant 3. Okay, we go from 180 degrees, 30 more, that leaves us with 210 degrees, or 7 pi over 6. We have 225 degrees, or 5 pi over 4. We have 240 degrees, or 4 pi over 3. Or we have 270 degrees, or 3 pi over 2. Alright, so once again, starting with our y value, square root of 0 over 2 is 0. Square root of 1 over 2 is just 1/2. But leave a little bit of room in front of your y's. I'm pretty sure you probably figured out why by now. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. And square root of 4 over 2 is just 2 over 2, or just 1. Now we go the other direction. Square root of 0 over 2 is 0, and leave a little bit of room in front. Square root of 1 over 2 is just 1/2. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. And square root of 4 over 2 is just 1, but we know it's negative. Now remember, in quadrant 3, your x is negative and your y is negative. Okay, so both of those become negative. No point in making the 0 negative. It's 0. Alright, so we do the same thing. Starting at our 0, or, well, I guess you could say going here, you can start at your 0 because you're starting with the y. That's why you don't start with the x equals 0. You start with the y equals 0. Okay, square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2 is just square root of 2 over 2. Square root of 3 over 2 is just square root of 3 over 2. And square root of 4 over 2 is 1. Then you go with this 0. For your x, you have square root of 0 over 2 is 0. Square root of 1 over 2 is 1/2. Square root of 2 over 2. And square root of 3 over 2. But remember, x is positive, y is negative. So all your y's are now negative. Okay, so filling in our radians and degrees, this is 5 pi over 3, 7 pi over 4, 11 pi over 6, which is 300 degrees, 315 degrees, 330 degrees, and this is your 2 pi, or 360 degrees. Also 0 degrees when you're just getting started, but once you go a full circle, 360 degrees. So this is your completed unit circle. Okay, so what you want to do is, like I said, go online and find a blank unit circle and fill it in, and just kind of practice going from 1, 0, then square root of 0, square root of 1, square root of 2, square root of 3, square root, and just kind of practice doing that a few times. Alright. Okay, so if you're still studying this, feel free to press pause. But we're going to go ahead and move on to our next, I guess you could say, next examples. Okay, a quick note. When your t is a large value, a terminal point can be found by adding or subtracting 2 pi, either once or multiple times. Okay, so for example, let's say if we have our unit circle. Okay, and from our unit circle, we're going to look at, let's say, pi over 6. So we'll say pi over 6 is somewhere around here. Help me clean that denominator up a little bit. So pi over 6. So we know that pi over 6 is right there. But what if we go from pi over 6 and we go one full circle around and end up right back at the same spot. That's pi over 6 plus 2 pi. But what if we go another circle around and end up at the same spot? That's pi over 6 plus 4 pi. Because remember, 2 pi is a complete circle. So if we're at pi over 6, a complete circle is another 2 pi. Complete circle is another 2 pi. Complete circle is another 2 pi. Even if we go the opposite direction. If we go negative, we can go pi over 6 minus 2 pi. Pi over 6 minus 2 pi. Pi over 6 minus another 2 pi. And we can keep on going and going and going in either direction, an infinite number of circles. Okay, so that means your t can equal t plus 2k, or 2 pi times some value k, or can equal t minus 2k, or 2 pi times k. Okay, so for example, what if we want to find the terminal point of t equals 25 pi over 6? Okay, all we do is we subtract multiple of 2 pi. Okay, so 25 pi over 6, we're going to kind of spread that out to 24 pi over 6 plus 1 pi over 6. Still 25 pi over 6. Okay, so 24 pi over 6, that simplifies to just 4 pi. As long as it's an even number times pi, that's 4 pi plus pi over 6. Okay, so if we had pi over 6 and we went 2 pi and 4 pi, we're right back at the same spot. Okay, so 25 pi over 6 has the same terminal point as pi over 6. Okay, so what is that terminal point? Well, we go to our trusty unit circle. We go to pi over 6, we see that our terminal point is square root of 3 over 2, 1/2. Okay, so it's square root of 3 over 2, 1/2. That's your terminal point. Okay, so that's just one of many tricks that you can use on a unit circle. Alright, so hopefully this video made sense, and I'll see you on the next video.